Okay, so this is complaining, although the other one doesn't complain, which is fine. I don't really think that I care about this one. I think that we were working in the this one? Yeah. Okay. So, morning Phil, how's it going? I think this is where we were working last time. So, what I was trying to do, or what I wanted to do, was generate an ID that is like unique for the particular socket. But then I realized that if if we pass over a TCP stream, we never need to like find that again, right? Like it's either going to just remain open or it's going to close. And so we don't actually care what this thing is, and we can just create like a random uh we can create a random atom, I guess. I don't know if there's like random atom, but we can certainly create like a um wait, what is this? Is this the new one or the old one? Because there are two random modules. This must be the new one. Because I would assume that there'd be like a deprecation warning. What's this? Okay. Um, this doesn't have like functions, which is a little annoying. There's only types. I'm kind of confused by that. But there's got to be a. These are all types, right? Is there no functions in here, or am I crazy? So these are random bytes. I don't really need like. So there's a like strong random bytes, for example. I feel like we don't really need that. Um, this is not particularly helpful. I think this is the old module. Mm-hmm. Not that helpful. What is this? What is earldocs.com? Interesting. I've never seen this website before. I don't really want numbers though. I suppose. No, this isn't like a. Let's do random string 10 character. I feel like I've done this before, but I don't remember how to do it. There you go. Look at that. That's totally fine with me. Don't really care. All right. So I'm pretty sure that this is relatively simple. So we can just do like this. And we'll just rewrite 3 shell just to see what this looks like. And I'm pretty sure we also can just like I don't know, 10. Yeah, I don't think any of that matters. So like I don't think the ID needs to be intelligible at all. I think it can pretty much just be this. And then so the whole point here is that given a supervisor and a socket, generate new and a new child with a random identifier. Okay, and then the other thing that we need. All right, this needs 10. and we need to pass the socket to the Starlink function because that's like the TCP connection that it's going to control. So yeah, this socket is like some TCP connection. We're going to pass that socket off to this chat server connection. And the other thing we need to do is we need to start the child with the temporary thing, the temporary flag, so that when it dies, we don't try to restart it because we don't want the supervisor to restart children. So we need to go to Erlang supervisor, and then somewhere in here we probably have like child spec, and I think it's type. Okay, it's restart temporary. Just so here we add restart is temporary. So this will say like if it dies, don't try to restart it. We just want it to just go away because that would imply probably that either the chat server failed or the TCP connection closed, and in either case, we don't really care to leave that open. You'll just have to reconnect or whatever. Oh, also. All right, cool. So from there, we now have a mechanism to start the child. We also need to have a Starlink function that accepts a socket. Look at that, we already accept a socket. So our Starlink function will accept our socket and start a gen server that contains it and does nothing else. So I think that's like the next thing that we're building. Cool. So in that case, I need to set up the book. 1 second here. So I bought this like I don't think I have like a mechanism to show this like in a nicer way, but I bought this like book holder. So you can like got like things so you can have it at different heights and stuff. And then it just has like a platform here. So that was like kind of a nice thing because the book kept falling over on me. And so I wanted to get like a little, like a nice, book holder because how this sits up. But I'm pretty sure that all we're doing is building this server next. It should be good. I'm pretty sure I got all the things in. Somewhere I need to fix the start child function, I think. Or I need to call that start child function. All right. Man, I am so staticky. Keep shocking myself. All right. And then we should just be able to open up Restream. Lovely. There, we don't like this. And all right, so here is our. So this is the. Yeah, so this is the acceptor. And okay. So this thing is complaining. We gotta finish our handle call. Just finish this really quick. So handle call is gonna have the message, the from, the state, and we'll just reply k state, and we don't really need this or this. And this is now wants handle cast, fine. handle cast. Again, if you've never seen Erlang before, the only difference between these two things is one is synchronous and one is not. So the call is synchronous, which is why you can reply, and then the async call is no reply and doesn't have this from parameter. So this is like the minimal gen server. All right, and then somewhere in here, we start our child process. So the chat acceptor has the start child. It takes who is my supervisor. Why does it need to know that? I'm trying to remember. So it needs to know that. Oh, right, because it needs to say who is the person that controls me. So I'm going to start a child under that supervisor, and I'm going to pass it this new socket. And once I do that, I pass it the new PID, that's the child that's created, is now becomes the controlling process for the socket. And then I just enter back my accept loop. So this thing just kind of sits and accepts TCP connection. That's its whole purpose. And then this purpose is to control the TCP socket. So we're good there. Let's keep going. Here's my start link function that takes my socket. The init just initializes the socket. Okay, and we need apparently a handle info function, which is going to take a message. I usually just do message state, and info function usually is going to be like no reply state for now. We'll see what happens here. Shouldn't have done it that. Info. Okay. Right. Need to use this function more. So GW is the jump function. So I can just jump around a little bit faster. Need to use that because my jumping around foo is very poor. Okay, so we're going to have a version of handle info which takes a TCP message. So it's going to take TCP socket data and the state, I guess. See? And the state, yep. And this is probably going to be like no reply state. And all right, what do we do with this? Okay, right. So this I recall dealing with this before. This update in function takes like a lambda that appends data to a buffer. So we have the socket as part of our state, and we're going to have a buffer as part of our state. And so if we get this, we need to update our buffer. So new state equals what? State there, buffer. Also we need to initialize our buffer. Oh, actually we can just initialize our buffer up here. We don't really have to the empty list like that. And all we're going to do is take the current buffer, so state buffer, and append the data. Turn state like so. All right. And so that's what that does. And then we need to set inet setup. Okay, I've never done this, but I'm going to guess we have inet setups on the socket. So we'll do state socket, and the options will probably be a list of tuples active ones. comma. All right, and then the thing is, these should match. So this should be like socket equals socket. So if for some reason the socket didn't match, then we would have a problem, right? Like it would be really weird if and then actually that means we can just write cool. So that's our first handle info. And then there's this handle new data function, and we do that with our new state. So handle new data state. Okay, and then that doesn't exist yet, so we'll find it. Data state, and we're going to say right. So we have chat protocol decode message state dot buffer bugger. And what are our options? Okay, message rest, I think, is exactly the shape that we defined. And we need to update the state. So we're going to say new state is state. What is the syntax I'm looking for here? Yeah, I want to do this. Then we want to say buffer equals rest. And what is handle message again? Okay, handle message is not defined yet. So we're going to say case handle message of guessing okay handle message. So this is going to take let's call this, I don't know what to call it. Because there's like two states here. So this is going to be handle new data state error stop delete is another option. Oh, this is not the right syntax. Okay, and then incomplete is just no reply. What state do we have access to? Just state, because there's nothing to be done there. And then there's some kind of error, which is just going to be logger, notice, invalid data. Buffer. Stop. Normal. What is this complaining about? Oh, that's a comma. Okay. So this is going to be new state. And this next state. No, this is also new. No, it's not. That would create an infinite loop. There we go. All right. So what do we do with... Oh, okay. This is going to... The message that we get out. So we're going to parse out our message, and then we're going to handle it. And if we get an okay, then we just keep going. Because like our buffer could get multiple messages at once. And then if it does, we want to process all of them and then go back into the handle info loop. Otherwise, we just keep going. So it looks like I'm pretty sure that this function returns errors as tuples. So we need to go say like, you know, error like this, error, error. We can see what the error was. And then we need to start doing this handle message function, which I think we'll read a little bit about this next. So I think this is right. Excuse me. It's definitely a little annoying that you have to like call this new state, but you probably want to, right? Because these must match, because apparently you can shadow names in Erlang, I guess. I don't know how the shadowing works exactly, but I would presume, oh no, this isn't shadowing. This is just saying these things must match. So if the state doesn't change, I think. I need to look this up because I don't know how Erlang behaves. Or sorry, Elixir. So Elixir, I probably just need to test this, wouldn't I? I'm going to make an assumption that handle message does the broadcasts and then just returns the state because it needs the socket. And then this is actually not, like, this is just the same thing. And then this can just be state. I'm going to make that assumption. And really, we can just say state here. Because those things would match. They have to be the same thing, basically. I keep doing... Because I write Haskell and Erlang almost primarily these days, I constantly mix up this the comment style, which is, I don't know, maybe funny. All right, so, well, we're gonna write this in a section. I don't need to write to do. All right, this initial code is quite similar to the connection handling in chapter 2. Yeah, you guys didn't, you didn't see me do chapter 2 on stream. Sorry, but this code looks incredibly similar to it. We're using restart temporary to ensure that these processes never get restarted by their dynamic supervisor. We have a dynamic supervisor, but it's not like an Elixir dynamic supervisor, obviously. The real difference with this similar code from the previous chapter will be how we write the handle message function that we call on line 35. Our protocol specification from specifying our says that a register message must be the first message that clients send after connecting. We can enforce this by looking at the username field in the connection's start. If it's nil, which is the starting value, then we know the client didn't send the register message yet. Otherwise, we know it's an invalid register message. That's what we're doing in the next piece of code. Okay. Oops. So handle message is going to have the register something, and then we're going to have the state, and we're going to store the username, this, because a single TCP connection is going to be a single username, I'm pretty sure. This, and then we can pull out the state or name. This. And then let's look this up again because I'm pretty sure that it's just register username. Username. And actually, what we could do is just say like this. And then we can say if we get anything else, I guess. Anyway, we'll figure it out. But either you put the case statement to match inside the register or you don't. It really just depends. We'll have to see what's the easiest thing. Anyway, so if we get register a username and the username is empty, we're just going to say okay state username equals username, and that's it. Makes sense. Yep. And then any other register message is just a straight up failure. Okay, so that's how they decide to shape it. All right. And we just state, I guess. Oh, this is actually an error. I lied. Error. And I'm pretty sure that this one is just like error. Okay, cool. So there's our register message. Either it's like nil. Is this nil? Where'd it go? It lost where I was reading. Oh, it was on the previous page. I guess this nil is just an atom, right? Like it's not anything special. I think I'll just use empty string to denote that. For now. Okay, cool. So we now have a basic server that can accept the connections and register clients. We can already write a basic test for the error case on line 10. This error, I guess. Let's hop into a new file and write the first test. All right, sure. I mean, I'm willing. Let's try this for sure. So we're going to open up test. Oh, sorry, I need. Now, do we want this to be a suite? Probably. We're using common test pretty regularly. So let's open up test module include this. This. And then we're going to write this test really quick. So, closes with double register config. Okay, we don't need this anymore. Close. All right. So, okay, client. probably supposed to be. I don't know what this C sigil is, so I'm just gonna assume that it's this. Say, sure, 4,000. I don't remember what I selected, and binary coded. Well, we can just say message. Chat protocol encode register with optical. So we should get OK, gen TCP, receive. Why is it not autocomplete? Oh, right. Then this is going to be client message. Wait, no, this is send, not receive. Talking about. Right, this is a receive. I see. I don't know how to do these assertions. We'll have to see. We're also going to need to like start this server here, I guess. Both of them. What time is it? So unit capture log. Can I do? Oh, but this is common test. Common test. Well, actually, it's probably still EU capture. Captured output. I'm guessing that this is the same, but different. It would be. I don't know how to assert that. Assert macros. I mean, maybe we just have like assert. I don't know. What do these throws do? I think assert throw is not really what I'm looking for. Yeah, I don't really see anything in here about like catching messages or anything. Maybe you just use the regular message functionality, and this is just like something built on top. So let's see if we can do this. So we should be able to say, okay, gen TC send client message. And then we probably want a receive. And then I think this just takes like TCP closed client. What is this 500? I feel like every single time I try to do thing, always click the wrong. Really want to ban them first. I always click the others. Anyway, so I think we just receive this. I don't know what we put here. Okay. Like that feels weird, doesn't it? I don't think this is gonna work. Okay, anyway, we can test. I don't think this is gonna work for numerous reasons, but oh, I need to bring in the other stuff. Um so there's stuff. We need to start the supervisor, which is called this one, chat acceptor. So called chat acceptor start link. Acceptor start link. This is going to give us PID. And I think we can jam the PID in the config to look it up and stop it later. But we probably don't care. It'll probably clean up after itself. We really just want to make sure that this A probably. All right, anyway. C tweet EP. All right. So let's see. We get some warnings about the export all, which is fine. All right, and then we get TCP connect. We get basically nothing. Function clause. Okay, so something about TCP connect is wrong. I think firstly, need to check that this was on the right port. Okay, right one. So first of all, it's not the right port. Five. Okay, and then also apparently this go Erlang function. So there's socket adder ops, address port ops, which is I think what we're using. Address ops. Guessing ops are a list of these. Port is a port number. INET is a host name, which is an atom or a string, so it cannot be this. Cool. So let's try this now. Can I save this file? I don't. All right. Bad match, error, connection refused, file, line 11. Okay. Hmm. Okay. I think that we just need to start goofing around because I really don't know. Oops. So firstly, we need to so this works, which implies that we should have a TCP server on 5000. So we should be able to say this. We can. I always forget how to do this. Okay. So we have the TCP server running. So that's great. And then this thing is going to go start. Okay. Now, we should be in an accept loop. All right. So we init this. We say listen on the port. If we get that, we hit OK. But we don't ever enter our accept loop. So I'm pretty sure that we need to enter the accept loop. And I think that's the problem here. So let's find out. Yep, right there. So we never actually entered our accept loop after we started the socket. So it will not accept connection. Nice. I really like that I can figure this stuff out now. Like, I didn't need the book to figure that out. Like I realized that I need to be in that loop, which made me feel. Okay, so anyway, so we can just get out of here. Well, actually, let's just try and run the test now. All right, we still get connection refused, which is unfortunate. So again, let's messing around. Oh, this got started. Oh, that's the Echo server. Okay, never mind. Um, wait. Why is that printing? Did that print last time? I don't think so. Anyway, okay, so to go to chat acceptor, so we're gonna say okay for chat acceptor Erlang. All right. So in theory, we have this started, and we started our accept loop, and then we need to call this function. That worked. Okay. So can we gen TCP send the oh, I need to this this okay, and then this now that's not what exploded here, which is concerning. Why not? If I run jet acceptor start link, it should just run. Unless that's failing silently, but how would that even happen? And it said line 11. So I don't really understand why this would, since this worked. Anyway, okay, let's go fix this. Go. Yes, you can't concatenate. Shit. We can't append binary data to buffer like. So do you just do okay, so buffer actually let's that this I think. Start on this. Then we do fails as well. Probably for something else, hopefully. All right. Handle new data. line 38. Oh, this is probably not. It probably is actually the message do again. Right, because it's going to set the username. Yeah, so it's not the same. I was going to write that down and then I never wrote it down. So you can see here, it's like, here's the current state and then here's the new state. So the pattern match failed because you can't have new state. It's going to be different. We could call this like new buffer, then call this it's not really new user state. It's like, yeah, we can just call this one. This one becomes buffer state. All right. And then we'll do, let's do, I think this will work. And then we'll have to figure out why it's failing in the test. Might be because it doesn't have access to the network or something. Okay. So in theory, this is fine. All right. So next step, let's just close that because we don't want. Excuse me. Okay. Actually, we can. I feel like there's a mechanism for me to make these bigger, but I don't know what it is. Try this one more time. Yeah, so we just get connection refused. So why is the question. So what if we move this down here? Does this change anything? It does, which is kind of interesting. So we send this twice. What if we do like this? What happens? All tests pass. That ain't good. So we should receive a message. Right? So what if we just do receive message logger message end? So now we're just sitting in this receive. Okay, I have got to remember how to time out. Receive Erlang after. Well, I don't know if this is the right syntax. So yes. let's say after like 1,000, just do assert. They're like just an assert fail. You can just say false, I guess. All right. Okay, chat acceptor terminating. I mean, that's right. But how do we assert that? I don't actually know. Hmm. Do I need to receive? Oh, maybe I do. All right. So I think we need to say case ntcp receive lion. Length. Should I just say I don't I'm not really sure what goes here. Let's just try this and see what happens. Nothing is logged. I think this is because common test is stealing my output. So I think what we're going to do is convert this to E. So to do that, because I don't really understand. Sometimes the this sorry, what is this thing called? Sometimes common test throws me for a loop. So then, okay, no, that's not it. It's tests. Whoops. We don't need this function. We don't need this function. Don't need these. This comes past. We no longer big function. Then we say like, okay, PID chat scepter start link this, and then I guess this is it. Be nice to close this and the client, although I think that's going to happen anyway. So then this just becomes unit. What happens? I don't know what that means. So this is this a thing here? Okay. So if the socket is not in passive mode, turn value is so. I don't really know if this is working. It's not clear to me that it's working. Receive a packet from a socket in passive mode. So this implies that the socket is not in passive. Okay. I don't know how to catch it. I don't know how to like convert this into Erlang. Kind of frustrating. If I can look. Elixir cert receive. Okay, the 500 is a timeout. Can I get to the source code? Is it just implemented as a receive? Yes. Receive after. Okay. So Try this. And then at least we can like okay, I just can't spell. Fine. True. Okay, what does this do? Just times out. Okay. So let's see here. Supposedly we've passed this to the connection. So let's see if we did. So we should be here. So we should be able to logger notice got data. Yeah? Okay. Try this. Got. Yeah. So here's our register. This is our first register. And then I don't see our second register here because otherwise we would see like a 1 and an 11. We don't see another 1 and an. So we got this. And then we should be here. Logger notice message rest. Okay. Logger handled. This one already. So that should be. This one also already logged. But also we should be hitting this. So what is it doing? All right. So we get message rest. Handled. So the new state is the port, empty buffer, and the username. That looks right. Why don't we handle the second message? It just doesn't do the second message. I don't understand that. Why not? never does anything with the second message. Huh? What? Is it this? Whatever this is? Oh, this is that. Okay. So now we get register, me, rest. Got it. We handled that. We set the username. We get an incomplete because there's nothing else to do. So we return. Then we get a new message, 111. We attempt to register them. Invalid register message. Errored message. TCP closed. There it is. Okay. So this is going to be TCP closed lion. Assert then this can really be 100 assert. There we go. Okay, found the bug. That was tough. That's a tough little bug. So basically what I was doing is I was returning a no reply, but I was never handling second message. Right? How do I explain this in my head? Right, I hit the incomplete, but I returned that whole thing as the state, I guess. And so it was like the state was messed up, and so we never matched the socket, and then it just did this. It just ran this to infinity, I guess. Or like it hit this and just did nothing. I'm not sure. All right, anyway, we can remove some of this logger stuff. We do want that one. Yeah, we do want it. Well. Okay, and then this should just run. God. That's like expected. Invalid data. Valid red. Oh yeah, this is just if it's like completely broken. So then this should run and these should run. Is that right? Oh right, there's some failure in here which that was there before. Anyway, so now we have the basic TCP going. We have a test too, which is pretty cool. And I need to go because it's way past my stream time. So next time we're going to deal with this broadcasting piece. So